First off, thanks for having us here. This is always fun, doing the talks. I don't know what Greg's doing, but
Where's the mouse?
I don't know. I'm more of a left button, right button kind of guy. There we go. We're using the buttons. So my name's Justin Borland. Started my career off at Atomic Energy. Greg and I actually met working at Atomic Energy. We'd known each other since we were about 13, 14. Right out of school, we decided we were going to start a company. And yeah, that's how that was formed. We did some work for RSA about 8 years ago and created a logging appliance that they front-ended their Envision sim with. And no, I didn't write anything that had to do with Envision. But I went from there to BlackBerry and then did some time in the SOC there, deployed some of their tooling for the SOC, namely things like DNS sinkholing, full packet capture, stuff like that. And then over at Equifax, I built out their full packet capture deployment, sinkholing, a lot of the operational stuff. I ran the countermeasures team for the incident that most recently happened, which was a ton of fun. And now I'm at Barclays, working with Nathan Fowler, Ryan Moon, Michelle Tyser, Juan Figuera, the rest of the gang over there. So yeah.
Okay, so I'm Greg. Unlike probably everybody here, I'm not in the security industry. I'm a software engineer. I've been doing that for about 13 years. I started off at Atomic with this guy, and I stayed there for a little while, about 5 years. And then I went into the banking industry, went into Citibank, Citigroup, whatever you call it, for about a year and a half, and moved over to RBC Capital Markets. I spent about 5 years there building trading software. We started Spark IT. We still run Spark IT. This is officially Spark IT Talk, I guess. And then now I'm at Thomson Reuters, which some of you may know about. They do the Reuters News Agency and Westlaw Terminals and Icon trading platform. So that's my bio. So a couple of things we've done. You heard Justin talk a little bit about the VLR, the Envision tool that we built. That was probably about 8 years ago. We built a UV Modbus, which is a Raspberry Pi-based solution for capturing logs off of Atlantium UV systems. It sits in control panels and sits there for about a year pulling out stuff, and then they send us the data. I built Salesbook and Tradebook at RBC, which is the global sales and credit trading applications. It's used worldwide by all the sales and traders. And Phoenix, which is what we're here to talk to you about today, which is a Cuckoo-based malware analysis platform. So I'll let Justin introduce Cuckoo a bit.
Sweet, yeah. So background, if you guys have used it before, I started using Cuckoo in 2011, working at BlackBerry. We had a need to triage binaries, find C2, sinkhole C2, go find more malware from those infected systems, rinse, dry, repeat. And it's been a pretty handy tool. Back in the day, we used to sandbox bar files for the BlackBerry phones before they kind of fell off the map a bit. But anyway, I started working at Equifax October 2012, and within 2 months, we had Cuckoo there. Frontline guys were able to submit binaries, and the goal was always to harvest the indicators, go and mitigate the indicators in a timely manner. And the reason for Cuckoo was mainly to speed up the OODA loop. So with us, we wanted to make it so that anybody could get these indicators out. You don't have to be a full reverse engineer in order to use this stuff. You just had to be tall enough to ride the ride, so to speak. The other thing was it did a really great job of taking all the data, putting it in a database that wasn't SQL, and letting you look at it and do, analyze it, give some context behind what's going on under the hood, right? The other thing is it wasn't that great. Cuckoo has its downfalls for sure. The biggest one that I saw was that they would go and index a ton of data and never use it. So it was always there. Things like the API calls, that stuff is extracted, and you can go and infer stuff from it, but it was just none of it was being used. And so a lot of the glue, a lot of the correlation just wasn't there. Some of the foundations were pretty good, but a lot of it needed some work. So, why Phoenix? The data simply wasn't being used to its full potential. You owe it to your data to analyze it, especially when it comes to malware. You're not going to get a good understanding of, campaigns, threat actors, and the observables that tie them all together unless you start looking at the data. And so the idea was always to create a workbench where your analysts could sit that was safe, that allowed them to build good controls. So things like, Yara signatures, Suricata signatures, process execution flow, that kind of stuff you could go and stand up a virtual machine, but there wasn't a really great spot for you to do that and look at all of your production data, which is, why we built this. So the goal was to go from finding a piece of malware to triaging it against your controls to figuring out if you have a hole that you need to plug, and then going and writing the control that you would need all in one spot. And that's kind of, it's a problem that's plagued a lot of incident responders, and that was the whole idea behind building this, is we need to get better and faster at what we're doing and how we're doing it.
Yeah, the idea behind this is basically to solve the underpants no problem, where you have your phase one, you collect all this data, you collect a lot of threat intel, and then phase two, phase three is hopefully you profit from it. But what we're seeing is, the phase two part is not all that well serviced by the current offerings in the market, so we built this thing to try and close that hole. So talk a little bit about the architecture?
Cool, yeah, so this is kind of how Cuckoo's laid out, if you're familiar with how it works. The top here, you've got your inputs. So in our case, we take virus total hunts, and those get, like if you've got a production Yara rule that catches emotet, for example, go and when you see new emotet, go and sandbox it. That'll hit the Cuckoo API. Cuckoo API then hits Cuckoo D, which is essentially the scheduler. Cuckoo D will then spin up VirtualBox and Cuckoo Router. And once the sandbox analysis is done, you use Cuckoo P to process the data. Data goes into MongoDB and Elasticsearch and some in SQL, and the data is then viewable and interactable from Cuckoo Web and Moloch by your analysts. So is everybody here familiar with Moloch? It's a full packet capture program, lets you look at packets and indexes, them 9 ways to Sunday. Very useful tool, especially when you're looking at command and control, exfiltration, that kind of stuff, right? So the workflow is essentially malware goes into Cuckoo somehow, whether that's your analyst pulling, files out and submitting it manually, or a programmatic hunt against VT, or better yet, a bro sensor sitting on top of all of your inbound email. And maybe you want to throw all of the inbound email to something like this, right? Malware is detonated, indicators are harvested. Indicators are compared against existing production controls. So things like a Yara list that you might have in blocking mode on your mail servers, or a snort rule that you have in blocking mode on an IPS, or if you have Tanium signals doing process execution for stuff that looks or feels bad, you want to basically triage all of that as fast as you can, find if there's any gaps in your controls, and then go and create a control, to stop what you're looking at, right? Hopefully without false positives. The other thing is you can use it to test your gold build. So if you have a gold build with a bunch of controls on it already, go and use that as your Cuckoo box and see how close to reality your sandbox actually is. The other thing is, oftentimes you'll find that one of your controls might have caught something, but you could also see it a different way, and therefore if you create, let's say, 2 controls, now you're creating a more defense in-depth type of approach to something that hasn't actually affected you yet. So I think this was you.
So some of the things that we wanted to implement in Phoenix that we're missing in Cuckoo were pretty obvious. One of the biggest things is having authentication. So There's no way to identify anything in Cuckoo as it is. There's no auth at all, but it's using Django, and Django has a really rich auth and admin system built into it. So the very first thing we did was turn that on. So now you can have actual accounts, and that leads to being able to have groups, which that leads to being able to have traffic light protocol. So one thing that Cuckoo doesn't do very well is basically sandbox the stuff that you detect from people that you don't want seeing it, keeping things internal to a company, things like that. Everything is just sort of out in the open all the time. So we built a traffic light protocol basically so that you can tag all sorts of stuff within Cuckoo, and either if your traffic light protocol is green, everybody can see it. If it's yellow, only your trust groups can see it. So let's say people in your company. And if it's red, only you can see it. And we integrated TLP into pretty much everything in Cuckoo and Phoenix. So Moloch is respecting TLP now. All of our hunts, which we'll tell you about hunting, is respecting it, as well as the actual submissions running against Yara and Suri, all that kind of stuff. We also implemented TLDR, which is a funny name for an API that can allow us to correlate our host and network indicators, and Justin will talk about that a little bit. We added 33 open VPN circuits so that you can detonate the malware and have it go over a bunch of VPNs in different countries. And we implemented a much more advanced search, which is funny because it's searching in Mongo instead of Elasticsearch, but we'll tell you about that a little bit later too. And yeah, so that and fixing a lot of bugs and just generally improving the quality of Cuckoo as much as we can. You want to talk about TLDR?
Yeah. Okay, so TLDR means exactly what you think. Cuckoo spits out a ton of data, and you really don't care about a whole lot of it. A lot of people use it as that initial, hey, get me what I need to go and block at my control. And so the data was always there. And so what we did was start looking at the raw requests, the raw responses, tie together stage 1 and stage 2 malware. So in this one, you can see the stage _1_MD5. You can tell that hash dropped the MD5 there, and you can also see where it came from and where it landed on the file system. So to me, that's something that I care about, mainly because bad guys can switch things up, and until you start measuring what these guys are doing and how they're doing it, you'll never know. And so a good example of practical application of TLDR is looking at where different stage 2s come from and how they're relatable with each other. So this is a good example. You've got multiple stage 1 files that are both leading to the same payload from different dropper infrastructure, right? And that's something that you care about if you're tracking threat actors or campaigns. It allows you to tie things together. It's something that you can say with certainty, these two are now related. And that's something that the data has always been there. It's just it was being dropped on the floor. No one really took the time to look at it. So for this particular API call, you can go and basically run through the gamut of your samples and start building a picture of what infrastructure is related to which threat actors, to which threat campaigns, and start painting a better picture of, the delivery, in this case, the delivery infrastructure.
So one of the other things that we found was lacking in the original Cuckoo was the ability to look at your recent submissions and get information for them. So really what they do in Cuckoo is you go to an individual submission by clicking on the MD5, and then all of the information is in that page, which is all well and good. But unfortunately, in some cases, you want to be able to actually see all this information in an aggregate or without actually going to each and every submission. So one of the first things that we wanted to do was add things like command lines and stage 2 URLs directly to the recents page, as well as to the advanced search page and all of that kind of stuff, so that you can immediately see the types of stuff that you have going on with your submissions and correlate them. We also added a bunch of basically data tables so that you can sort, you can search, you can filter, you can do all sorts of good stuff, you can paginate, just to increase the richness and the functionality of the recents page and the search and all that kind of stuff. Yara? Yep.
So one of the other things that we did was we implemented Yara and Suricata Hunting natively within the Cuckoo UI. So you get malware samples compared against your controls. Oh noes, I don't have a control for this. Well, now I need to go and write a Suricata rule or some type of Blue Coat proxy, CPL block, something needs to happen so that I can make sure that I'm protected from this, right? And what we did was, since all of the analysis have TLP in them, you can now hunt against stuff that you're able to see via TLP. So let's say you want to test a new rule out. You go and submit it a bunch of times as TLP red while you're testing the rule out. Once you get the rule working and it works as intended, maybe you move it to TLP amber. And then when people in your trust group go to the Yara hunts page, they'll see that someone else has written a Yara rule and it's caught X. So now you can start collaborating a lot more with the rules that you're writing and the controls that you're creating, not just, via email or some other thing. It's like you can go and click the rule that someone wrote in here and download it and add to it or whatever, right? So same with Suricata hunting. You write a rule, you want to go test the rule, figure out what, network traffic it hits. It's all done under the hood. It's all done in Docker with the idea that you might want to scale this sideways. You might want to, one day you might have an S3 bucket that you want to go and hunt with Yara or whatever. And we figured that Docker was probably one of the better ways to go with this because as you'll see in some of the later slides, containerization is somewhere where we're headed. We're not there completely yet, but we do use it under the hood for certain things. This one's to you, Greg.
So Cuckoo natively has a search page, and basically what that does is it takes whatever you type and jams it into Elasticsearch and searches all the fields. Unfortunately, the Elasticsearch in Cuckoo doesn't have a lot of the data that does exist in the MongoDB database or whatever database you're using. So we decided to basically reinvent the advanced search and be able to search through all of the Moloch data. There's also a ton of fields in Moloch, and you want to be able to search across multiple of them. So essentially we came up with these mappings that you see in front of you here. It gives you a big list of sort of aggregated search fields like port or CLI or so on, and that will go and actually grok all that stuff out of Mongo for you.
Before you go on there for a second.
Yeah.
So one of the reasons behind doing this was the more you know your data, the easier it is to find what you're looking for. And if you go, I'm been at Barclays for 4 or 5 months now, and one of the first exercises I did was, they're a Splunk shop. The very first thing I do is, okay, what observable types do you guys even have, and where do they live? And when you can map this, which is what gets detonated and the indicators and stuff that you plan on harvesting, when you can match that up with where you would potentially look within your environment, it makes going from indicator harvesting to indicator processing very quickly. And that's part of why that was a fun exercise.
So we find a huge amount of value in the advanced search simply because you can extract and filter a lot of data that you never could before with Cuckoo because it was just simply hidden. The only way to get at it would have been to go to each and every analysis page and dump it out. So this is actually giving you the ability to do that. We also integrated a more advanced query builder, so you can basically take all of the factors facets that you want and combine them into a large query. That way, this is an example of us looking for something that matches emotet, and it matches it all the time. And you can combine things with a Boolean query so that you can get really, really fine with it. One of the first things we're going to do later is to basically be able to encode this into URLs, something like that, for easier sharing. Right now, it's in a post. We'll turn it into a get.
Go back for a second.
Oh, yeah.
So this is an example of when we were sort of hunting emotet and what emotet looks like. And if you guys are familiar, you'll know that this is a very static string. If the command line contains that obfuscated is set string, you're probably dealing with emotet. And so they kept changing up their delivery mechanisms. They might increase the number of random characters, but it's always like head smash with a trailing slash and that kind of thing. And one of the first use cases behind advanced search was to say, okay, I get that emotet is dropping binaries. I have an understanding of what the binaries are. How do the binaries get from the wire, from that other server, to my system? Are they using compromised servers? How are they setting this up? And since we already mine and index the raw response, it became a whole lot easier to start looking at this stuff and essentially create a control for the response of an emotet binary. And what we found was that they always had pragma no cache set. It was always application octet stream. There was always a content disposition with a file name that you could have a regex parameter for, which was all numbers. And so all that was always present in the stage 2 delivery. So now I don't need to care about what the URL scheme of the day is anymore. I understand that if it's coming down over the wire using this, it's probably bad, right? And so now a lot of people spend time, hunting the lures, and there's value in all that. But for this, at the end of the day, payload gets delivered like X. Let's write the control for how the payload's actually being delivered.
So another thing that we wanted to do with the advanced search is be able to take all of the stuff that you've just dumped out and be able to send it all to Moloch. So what we have now is whenever you run an analysis in Cuckoo and it runs it in Moloch as well, it will tag it with Cuckoo and the analysis ID. So it's a fairly simple exercise for us to be able to craft a URL that actually brings up all of the various things in Moloch that match your advanced search. A little bit trickier was getting Moloch to respect TLP. Which we'll talk about in a little bit, but this is just basically showing you how you can take all of the stuff that you've just searched and dump everything related to the network into one screen. And the analysis stuff?
Yeah, see, I just see blonde, brunette, redhead, Just so everyone's following along at home, there's a View in Moloch button. So once you have your query the way you like it, you can just say pivot to Moloch, and it will go and take the stuff that you just found, dump it in Moloch. So now you can start hunting the network indicators by themselves after you've gone and hunted via a host-based tool. So you're going to be able to write the controls for the whole family and look at the family as a whole, as opposed to looking at one or more samples of this, right? So this happens, I'm a sucker for visualization, and to me, this is very apparent what I'm seeing. The dots in the middle are the domain or the host header within HTTP, and the dots surrounding it are the MD5 of the response body. And what you'll see is the ones that look like little circles, little flowers or whatever, those are exfil. That's stage 2 plus. So the payload is changing when they're going back to their C2. They're going and siphoning data out, and the payload's different, and by virtue of that, what you see is a little, flower. If you want to start digging into the network traffic, it's easy to go, find all the posts. Those are going to be your exfil. The gets are probably going to be your droppers. So let's look at just the gets. When you look at just the gets and you have all of this behind one pane of glass, one of the things that you can understand and see is that certain domains and certain payloads are related. So this is the dropped MD5, and this is the host header. So this payload was dropped from these two. This payload was dropped from these four, but this host also dropped, a different piece of malware. And all this data was probably there before, and people just weren't looking at it. And the hope is that we've lowered the bar enough that people can start taking a good, long, hard look at the malware as a family and not just as a one-off sample, right? And start profiling the delivery infrastructure, the C2 infrastructure. Let's get everybody looking at this because, 4 sets of eyes are better than 2 and 8's better than 4. Is this you?
So when we set out to build this thing, we knew that TLP was going to be a really big deal. And we knew that any gaps in TLP were going to be a really big deal because, like we said, Cuckoo had no way of controlling anything like that in the first place. So if we're going to do it, we have to do it right. So TLP and Moloch was probably the toughest nut to crack, I guess. The way we ended up doing it is that Moloch has a concept of forced expressions, which basically means that if you are user A and you go and do a search in Moloch, then whatever's in the forced expression will essentially be appended to your search. And those forced expressions are stored in Moloch's internal database. So now that we have users in Cuckoo, we also automatically create the users in Moloch, and then we also attach a forced expression to those users that basically just lists out all the individual Cuckoo tags that they're allowed to see. So you can see here all of the various users. Obviously, we've blanked out the actual user ID and names, but they all have a forced expression that allows them to see only very specific Cuckoo tags, and that way we have TLP from end to end across the entire application, and nobody can see what they're not supposed to see. Yeah.
Cool. So yeah, now that you've got a place to collect all this data, it gives you a better framework to go and start hunting the bad guys that you care about because they care about you. And what that means is if you're getting certain flavors of mouse spam every day, you should probably start trying to create controls like Yara signatures to go and profile that family of malware. And what you can do is then put it up on VT, and I know not everybody has it, or Reversing Labs, actually. I should plug them because they're not owned by Google. Anyway, programmatically submitting this stuff based on the Yara signatures that you specify has great value, because then you can harvest all of this stuff, you can detonate it, you can harvest the indicators behind that, and then you can go and push those to your controls in a very timely manner. I'm a huge DNS sinkhole fan. Populate an RPZ, have your analysts look at this in near real time and go from seeing an email come in to having it blocked at all, globally within 10 minutes is not unachievable, even in large environments. The other thing is, once you start collecting this data, there's no reason why you can't map their infrastructure. There's no reason why you can't understand why they prefer delivery server X over delivery server Y. Maybe they have a penchant for Nginx servers because they're compromising them. Until you start looking at the data, you'll never really know why they're coming from where they're coming from. And this gives you a place to do all that work centrally.
Okay, so that's where we are now. So where are we going? Well, one of the biggest things that we've been working on in the last few days is an easy button. So the stuff that we've added to Cuckoo to create Phoenix has really gone well beyond the scope of Cuckoo itself. And to begin with, Cuckoo had a bunch of stuff that you had to do to get Cuckoo to work in the first place. Now, Cuckoo has released their new 2.0 version, which has a better installation, better packaging, and that sort of stuff. But there are still a lot of manual steps to be done. So one of the things that we wanted to do is make that a lot easier, lower the bar, make it easy to deploy on multiple systems quickly, and also to port it over to different systems like Ubuntu. Is it Ubuntu or Ubuntu? I don't know. I'm a Windows guy. No, I'm kidding. So one of the things so installing dependencies is a big one. There's a lot of stuff that this stuff uses. There's probably a good 34, 35 packages that we install with this thing now. Yeah. All the OpenVPN configs that we've supplied get automatically copied out. We install VirtualBox for you. We put the OVAs in for you. We add the VirtualBox interface, the user, the drop user, set up fail to ban for you, create certificates, all the stuff that you can see, just making it really easy. You have a question there?
Quick question on that, because we ran into this recently. All of the configuration scripts are staged in an install directory. How do you go and actually set the user up? Do you have to run commands as user X in order to do something like install a VirtualBox OVA? So I'd love to catch up a little bit later, because
grab you after for sure.
There's a lot of code that's not that pretty, but it works. And you'll see when you go through this. A good example, I think this is. Let's just go ahead real quick. Can anyone tell me what this does?
I didn't write that.
5 minutes? I wrote this. This is, yeah, just so everybody knows, it wasn't Greg that wrote this.
The name is fixopenvpn.sh.
Right.
That's a good script name.
Right, and this is one of the nuances that you'll learn under the hood if you do play around with OpenVPN and maintaining 34 or 35 or n number of OpenVPN tunnels, is that certain things break at an operating system level, and you need to do things as both a user and as root. And there are root components to this, and there are user components to this, and that's, from a deployment perspective, this gets run every minute. Every minute the routing tables for all of the VPN interfaces are rewritten, overwritten, and forced back out the other end of the VPN tunnel. Mainly so that everything is always working, because VPNs are flaky. And a lot of this stuff, you might have 28 of them that work really amazing, and then some that flake out on you all the time. And this was one of the tricks that we found to make sure that everything worked all of the time.
Right. So, and this is one of the things that we're really working on. Is like Phoenix is a very large system. There's a lot of components, a lot of duct tape holding it together, and so we're trying to take that and make that a lot more production happy, enterprise ready, if you will. But it's it's a longer process, but we're getting there. So I think we talked about the installation files a little bit. This is basically a list of the stuff that the Easy button is going to take care of for you. And yeah, to your point, I mean, we're also going to try and make this so that you can integrate it with Chef or Puppet or any of these types of configuration management systems to make it more, deployment at scale a little bit easier. So that's the eventual goal. The first thing we want to do is, make it really, really easy to deploy it on one system or multiple systems without a lot of, messing around. And that way you can fast forward to phase 3. So, Justin mentioned Docker earlier, so Docker is definitely something that we're investing heavily in the system. The first thing that we used it for was for the hunts. So Suricata and Yara both have their own sort of threading, but we were able to make demonstrable gains in performance by actually essentially threading it out using Docker containers instead of the actual inbuilt multi-threading and stuff like, especially in Sur. So that was a big get for us, and one of the things we want to do with that is farm that out to a cluster, like a Kubernetes cluster or something like that, and really scale this sideways. We also want to be able to orchestrate all of this stuff so that we can, have a really easily managed cluster of Docker containers running our hunts for us and running everybody's hunts for them. It also makes it easier to use different platforms. Docker is very much a write once, run anywhere type of system. So if you want to be able to, build a cluster of, any kind of Linux flavor that you want, Docker generally is going to be able to make it happen for you. It also allows us to separate our dependencies. So one of the big problems with Cuckoo is that it has hard dependencies on a lot of stuff like Python, like the Yara Python library, and they're not always the latest and greatest. So we wanted to be able to use the latest and greatest in all of our hunts, so Docker allows us to do that by basically having a little Docker jail instead of having to use virtual environments in Python.
I'm going to skip this one, I think. Scaling, yeah, it has to scale. There's the link for this if you guys want to go and try it out. The thing that I will say is that the reason why we had to go and do the easy button was because Cuckoo is an implementation of something that can be done many different ways. You can use Postgres for the back end. You can use MySQL. You can use any number of different SQLite. A lot of it is mix and match. You can run it on Ubuntu. I run it on CentOS. So this was a good exercise in migrating everything that was CentOS based over into Ubuntu so that you could basically take all of the components, make sure you understand how they work and interact with each other, and then rewrite everything for a new OS. But yeah, it's more, this is how we've done it, and if there's one thing that you should take away, it's that you probably shouldn't go and just run the easy button. It might work, it might get stuff up for you, but I would suggest maybe looking at the commands line by line and seeing what we're actually doing in order to glue all this stuff together, because it's not black box magic. It's free software that everybody should understand how it works. You don't need to spend $500,000 a year on a FireEye box if you've got smart people that you employ. And that should be your goal, is employing smart people and not buying the shiniest Ferrari. So
we're also planning to, as the slide mentions, contribute a lot of this stuff back to the main Cuckoo branch. They have kept the legacy branch with the 1.x stuff, which is what we use because we pulled this over a year ago. So we're going to be contributing to that, and then they'll be helping us manage the port up to X. But the fork is there for anybody who wants to pull it down and take a look at it. Like Justin said, look at the easy button, because that's going to basically tell you exactly how Phoenix works and how it fits together, and that's, in my mind, one of the best documentations that you can have. And we're going to get rid of stuff like that. Yeah, we're going to get rid of stuff like that as much as we can. Yeah, so
we're good. Yeah, no, I think that's it. Any questions, comments?
I have a couple of questions about scale. Moloch has been really kind of rickety and held together with tape and spit, developed by AOL. How many PCAPs do you have in your Moloch right now?
This one, not that big. I actually just came back from speaking at the Moloch Con up in AOL. So full disclosure, I ran a 1.9 petabyte deployment at Equifax. So when you say it's held together by duct tape and spit, it really depends on how you built it. Again, if you spec it wrong, it will behave that way. We spent a lot of money on the newer deployment for 20 gig boxes. Used solar flare cards under the hood. I wouldn't do that again. I would go with Intel 10 gig NICs. But the ricketiest part of Moloch was always Elasticsearch. And if you have good Elasticsearch admins and you take good care of ES, then it works a lot better. We used a tiered storage deployment with Elasticsearch where everything gets indexed into Fusion IO SSDs for 12 hours. And then after 12 hours, it gets optimized down to one segment, force merged down to one segment, and then moved to spinning disks where it's only ever sequential read. Big performance increase there. You're not spending all your money on SSDs either. So if you want to talk more about Moloch,
Yeah.
I have a lot of tips and tricks. I've ran a pretty large deployment of that. That's, one of the big tools for the Equifax incident that we used.
And then the other question is about, did you make Mongo fast enough in Cuckoo to really be able to do those searches? Like, how fast?
a lot of indexes.
There are a fair amount of indexes. We haven't really tested it more than a few thousand samples. The main problem that you'll run into before you'll run into that problem is the 16 megabyte document size maximum that Mongo has. And so that is more of a problem than the scaling of Mongo itself, because if you really want to, you can just shard it out and throw hardware at it.
And ideally, too, we want to do something that's a little more sophisticated than Mongo. I mean, Mongo's a great general-purpose document DB, but there's plenty of better tools out there for this particular application. I'd love for it to be in ES or something like that, but Mongo is really just a means to an end right now, and that's something that we would like to address.
And you're running with Mongo for everything now in your Cuckoo?
There's Mongo and Elasticsearch.
Okay.
And SQLite.
Yeah.
Got time for one more quick one.
Cuckoo's fun like that.
Yeah.
So I believe my credit card is in your 1.9 petabyte of PCAPs.
Oh, you want to talk about this? Okay.
No. I don't. I just wanted to point out.
No, you probably know better than me. Go on. Let's see this.
My question for you is, what is the average time that it takes for you to go from a sample to a control? Average amount of time, or guess.
For that emotet, it took me half an hour to sift through all the emotet data and write a snort signature and a blue coat CPL for the response binary. So
This is all about tightening that time up as much as we can, right? The more minutes we can shave off of that, the better.
yeah, just you don't want to be the next Equifax, right? So
Well, thank you, Justin and Greg.
a lot of people joke around about that, but that was your security folks in this room here. That's a badge of honor, and the fun incidents are the ones that make it into the news, right? I'm still under a federal grand jury subpoena, but we'll talk about it one day, maybe 20 years down the road or something. Once that's
All right, thanks, everybody. Is this yours? Or is this
no, that's theirs.